Hey guys, welcome to another algorithms tutorial video. In this video, we'll be calculating simple arithmetic expressions using C++. Now, by simple arithmetic expressions, I mean something like this. This kind of expressions that we generally use in many calculations, they are in terms of representation are called as infix expressions. Why infix expressions? The reason is that the operators like plus, minus, or these kind of operators, they reside in between or in two operands. Calculating these kind of expressions as they are is possible. We can just write a recursive parser which will take precedence for the higher order operations like for multiplication, division, and then in the second recursive call they will go through these addition and subtraction operations. But another approach that I will be showing you today is that we will be converting these infix expressions into something known as postfix expressions. So postfix expressions, and the postfix expressions for a simple example looks like this: 1 2 plus, okay, and then suppose 3 minus. So what I mean by this is that first there will be two operands, then there will be an operator, and we will calculate these two operands depending on this operator. So this one will become 3, okay, so this one will become 3, and then we will once again have two operands like 3 and 3, and then we will take the operator like this minus, and then we will calculate them, and we will have something like 0 in this case, because 3 minus 3 is equals to 0. So first things first, what we will do is we will convert this infix expression into a postfix expression in such a way that the order of the operations will be rearranged. Now what I mean by rearranging the order of operation is that in case of calculating, like if I am calculating this one expression, the first thing that I have to do is I have to do these operations. These operations I will have to do these operations first, and after that I can go with doing these operations like adding these things. Okay, so for an example, in this case, like I have a 1, then I have 12. In case of if I convert this one into an postfix expression, it will look like 1, then 12, then 3, then I will perform division. So first things first, this 12 and 3, they will be divided, and then they will be added with 1, and then we will have 4, and we will have 2, and then we will perform multiplication, and then this multiplication of 4 and 2, they will be subtracted from the result. Okay, so if I go here, the last two operands will be these two, and then we will perform division. So this will become 4, and then if we see after division operation, then these two will be added. Okay, so this 1 and 4 will be added, and it will be converted into 5, and now we can see this that the last two operands 4 and 2, they will be multiplied, and they will become 8, and after that 8 will be subtracted from 5, and the result will be minus 3. Okay, so this will be our approach: first converting this infix expression into a postfix expression, and then solving it by the way that I mentioned. So without further delay, let's get started. So as you can see in this problem, the multiplication and division, they get higher precedence than the operators like addition or subtraction. So to do that, we will define the precedence for each operators. So first of all, we will represent everything as strings, so to make our life a little bit easy, so include string for that, and we will be declaring a map to represent all the precedence of the operators. So include unordered map for that. Okay, so first things first, I will declare an unordered map of a string which is the operator and its precedence, which will be an integer, and I will call this OP map. Okay, a very bad name, but it works. So it will have the operators like multiplication, let's say, with a very high precedence, like let's say 3, and then it will have other and then it will have other operators like let's say division, and then addition, and then subtractions. Multiplication and division, they will have the same operator precedence like 3 and 3, or let's say 2 and 2. And for addition and subtraction, let them be 1 and 1. And for having the functionality to use brackets, let's also include brackets here. We will deal with the brackets a little bit differently, and we will just give them for now a precedence of -1 and -1. It doesn't matter what precedence we are giving, because at the end of the day we will be dealing with the brackets in their own way. Okay, so it doesn't really matter, but for the sake, let's give brackets -1 and -1. So this one is my OP map. I can get the precedence by simply writing something like this. Let's say OP map and then the operator. Okay, so let's say in this case multiplication, and this will give me the value of 2. Okay, so we have this kind of operator precedence map. Now let's take an expression. So let's say a string expression, and let's get the expression. I'm using getLine because this is a demo application, so we can just simply get that application using cin and then passing expression like this. And then for now, let's first see if the expression is we are getting the expression correctly. So cout, let's say expression. Okay, let's just run this and verify if the things are working correctly, nothing else. Now let's type a operation like 1, like let's say. So now let's type a expression like 1 plus 3, 1 plus 2 minus 4. Now you can see that we get this input correctly. And the first things first is we have to separate each objects like these operators and operands into single units. We will be calling them tokens. So let's and store them. So for storing purpose, let's use vector because it's a dynamic array and very easy to use. So vector, and let's create a vector. Let's say vector of strings, and we call these tokens. And these tokens, they will be created by using a function. Let's say call it tokenize, this function, and this tokenize function, it will take the expression and the operator map. So we can define this tokenize function here. Okay, so let's say vector of string tokenize. It will take a string expression and unordered map of, let's say, string comma operator int, and let's call it OP map. It doesn't really matter what names you provide them. You can even sort this thing into some kind of type def, but it doesn't really matter, so I'm not going to that. So first things first, we'll have to tokenize. So the tokens, we will call them we will declare a vector of strings, and we will call these vectors tokens, which will be blank initially, and we will have a string that we will use to parse. So string temp equals to an empty string. Now we will go through each character. So for, let's say, char C belongs to our expression, what we will do is first of all we will check if the character is a space. If it's a space, then we will just simply continue, because we want to ignore all the spaces. Spaces doesn't really matter. If they're not, then we will check if they belongs to one of these, then we can say that these are operators. So to check that, we will simply say op map dot find, because unordered map provides us a function called find, and we will find for a string. So we will convert the character into a string. So string string constructor will be called, and the string constructor, first parameter is how many characters are there, and second parameter is our character. So 1 comma c, and this op map, if this is not equals to op map dot end, find returns are iterator. If you don't know what iterators are and how to use such data structures like unordered map, I will recommend you that you go and check my algorithms, C++ algorithms and STL series, the STL algorithms and containers series, and you will find their unordered map and functions like op map and the concepts like iterators. So you can definitely check it. But for now, I'm considering that you know that. But the basic operation is if the character is an operator. That was what this condition checks. So if the character is operator, what we will do is we will first of all whatever token that was there, we will first push that, because the operator, it appears after operand. So tokens dot push back, and the current operand we will push that, and after that what we will do is we will empty our current operand. So temp will become empty, and after that we will push our operator. So we will say tokens dot push back, and we will create a string out of our character. So string 1 comma c. Okay, so that's how we push our operators. Now if they are not operators, then they are operands. So in that case, we will just append the operands into our temp, because it might be that the operand is like 112.22. okay, so until we reach an operator, everything will be added to token. Until we reach an operator, everything will be added as token. Okay, and then when we reach the operator, the first thing is that we are pushing that token, then we are making that token empty, and then we are pushing that operator. So in all other cases, when they are tokens, so else what we will do is we will simply say temp plus equals our character, just like that. It's very simple. Now in case of infix operations, if we see in infix expression, if we see, then after all the operators are done, let's say 2 plus 1 plus 3, there is one more operand that is not pushed into the stack. So there will be one more. So what we will do is we will push that operand into tokens by simply saying tokens dot pushback, and then our operand, so which is temp. Okay, and then we will return our tokens. Now we can simply check it, these tokens. So we can write a for loop, like for, let's say, string string token belongs to tokens, we just simply print the token, and then we print end line. Okay, to check if our tokenizing is working correctly. So now let's give something like 1 plus 3 plus 2 plus 4 minus 4 by 3. Okay, and unexpectedly we got some errors. I don't know why, so let's look into it. And there is here, if c is equals to, I wrote c is equals to, but it will be c double equals to. So if I run this now, because this is a condition, okay, this is not some association, I am not setting the value of c, I am actually putting a condition. So let's say 12 plus 3 minus 4 by 23.4, and as you can see we have a list of tokens like 12 plus 3 minus 4 divided by 23.44. So our tokenizer is working correctly. So now that we have tokenized our tokens, these tokens, they are in our infix form. And now the next thing is that we have to convert them into postfix. So the next thing that we will be doing is we will say tokens equals to, because these tokens are in infix form, so we will convert them into tokens in postfix. So tokens equals to infix to postfix, if that makes any sense. And this function will take our original infix equations tokens, so we are just rearranging the tokens to be simple. Okay, tokens, and also we will need the operator map in every cases. Okay, so now let's write this one, that is we are converting into from infix to postfix, and put it right here. So we will say vector of string, let's just put some space here. Okay, so let's say vector of string, because we are returning tokens also here, and we will call this infix to postfix, and it will take a vector of strings. So it will take a vector of strings called our infix. We can also take this via its reference, because we are not actually going to modify this, we are generating another vector of strings, but it doesn't really matter. Okay, and we can also not take them as references, it depends on the user. And we also use the unordered map of string comma int, that is our op map, because op map is really a op. Okay, so now that we have this function, we once again create a vector that will denote our postfix. So vector of string string, we will call this str string, we will call this postfix, if I spell it correctly, and then we will simply return that. Okay, and let's declare it as an empty vector. It doesn't really matter, but I like to do it like this way. And to do that, we will take the help of a data structure which is called a stack. Now a stack is like a vector. It can you can push a value into the stack, and you can pop a value from the stack, and the top element of the stack, it can be represented as vector dot back. Okay, so we can simply use a vector for stack. Now if you don't know what stack is and why stack are used, I can create a video for that. But in general, you can just google it out what a stack is. Stack is a popular data structure. If you are from computer science, then probably, or if you are working on learning programming, then probably you will learn about stacks, or you will use stacks at some point. For now, let's just consider a stack. So vector of string, string, and we will call this stack. Okay, so this stack, you can consider it as a bucket, okay, where you can insert elements one after another from only one end. From, let's say, you can insert from this end, and you can also delete element or pop element from one end. Okay, so you can insert elements from one end and you can delete elements from one end, and at a time you can only look at what is at the top of the stack, like in this case this one. Okay, so this is all about stack, the representation of stack data structure. So now we have this. First of all, we will push a bracket into infix, because if we consider a equation like this, let's say a plus b, we can also think that we are considering it like this. Okay, and the only thing why I am doing this is because the reason is simple, and the reason is that I want to support the use of bracket, nothing else. Okay, if you think that there is some other motives, then I am very sorry, but only to support the use of brackets we need to go through this little hack. That is, we are just going to push and bracket at the front. Now the other things are very simple, like the same. So we'll go through a for each loop. So for string token which belongs to infix, we will just loop through those strings, and first things first, we will check if that thing is an operator or operand. So in this case, let's go at the first one we went with operator, so this time let's go with an operand first. So if, let's say, op map dot find our token, because the token is already a string, so we don't need to convert it like before, is equals to op map dot end. That is, our item is an operand. You can simply check it in different way if you are writing, but I'm just using a unordered map to just facilitate the time. Okay, nothing else. So what we will do, if it's an operand, we will just append it to the postfix. So postfix dot push back and then token. Okay, just like that, and it's done. And if it's a bracket, then we need to also do something. So if token is equals to, let's say, opening bracket. Okay, if our token is an opening bracket, what we will do is very simple. We will put that bracket into the stack. So stack dot push back our bracket, opening bracket or parenthesis, whatever you feel comfortable with. Okay, for me all these things are bracket. And also we should write this as else if, because one of these conditions are going to be true. So else if doesn't really matter, because one of them are going to be true. If you just write ifs, it will be fine. Else if the token is a closing parenthesis or closing bracket. So if the token is this, okay, then we need to get everything out. Okay, so to do that and put them in our postfix. Okay, so to do that, what we will do is we will say postfix, we will write a while loop. So we will say while stack dot back, which is the top element of the stack here, is not equals to a parenthesis. Okay, opening parenthesis. What we will do is we will append it to the postfix. So postfix dot pushback stack dot back. So the top element, it will be pushed back onto the postfix, and then it will be deleted from the stack. So stack dot pop back. Okay. It's this will be stack dot back, not emplace back. Okay. Emplace back is equivalent to pushback, so it will be like this. So we'll take the top of the element from the stack and we'll push it onto our postfix. And for the last one element, what we will do is we will pushing this one in advance. Okay, so for the last push we will go all the through to this one. Okay, like that. It's very simple, and actually it should be more like this. Okay, I did some mistake. So for the last parenthesis, it will push all the things that are in the stack. So the stack should contain this one. So the stack should contain this one. So what will happen is, let's say we have some elements into the stack, and then our expression suddenly ends. So when our expression ends, what it will do is it will see that in the infix expression the last operator is this, and whenever it will see this, everything that are in the stack, they will be pushed to our infix, resulting in emptying the stack, so that not a single element of infix is in the stack after we are done with the conversion. Okay, sorry for the mistake, but this is how it looks. Okay, I didn't look at it properly when I was writing. So after that, we have pretty much done with it. So we have pushed all the elements until this. So the last one is this one. So obviously the last one we don't care, so we'll just pop it out. So stack dot pop back. Okay, and we will done. And now if that is not the case, then we are sure that we are having an operator. Now in case of operator, let's comment it as operator. Operator means plus, minus, multiplication or division. We will do something special. We will check until the highest precedence operator is reached. So if, first of all, we need to check if the stack if the stack is not empty. So stack, because if the stack is empty, then we have nothing to do. So if the stack dot size is greater than 0, and that is the stack is not empty, and our op map token token token, because the token is in this case an operator, so it should exist in our op map, should have a higher or equal or a lesser or equals to precedence value than the top of the stack. So op map stack dot back. Okay, so what the hell did we do here? The thing is simple. Until our token has a more operator precedence than our top of the stack. So first of all, what we will do is we will postfix dot pushback stack dot back. Okay, and then what we will do, did I make a spelling mistake? No. Oh, this will be pushback. So postfix dot pushback stack dot back, and then we will say stack dot pop back, and then we will push the token on the stack. So stack dot push back our token. So what we actually did is, whenever the stack, it contains some higher precedence operators like stars and divisions, and we have a lower precedence operator like plus, what we will do is we will first of all put these things out, and then we will put plus here, and the star and division, they will go here. The result will be that these operations, they will be done first and then the plus. That is our main motto of using precedence. That is, we want our multiplication and division operations done before our addition and subtraction operation. So this is just that until we reach to the same operator precedence, we will just get all the elements out of the stack and put them into postfix, and then we will finally put our current operator in the stack. Okay, and it's done actually. So we can return the postfix. Now we can simply check if it's working by running the same code, because the tokens are now converted into postfix. So if I run this and I give a simple example like 1 plus 2 by 3, we can see that 1 2 3, then first we are doing division operation and then we are doing addition operations. So our infix is being converted into a postfix. Okay, so it's been done. Now the last thing is calculating the postfix. So we will say float calculate postfix, and it will have the same kind of declaration. So I'm just copying this thing. It will have the same declaration. It will take the, I'm just writing these functions differently because as a logical way to express that we are doing these different operations. Okay, and in this case we are using a postfix one. It doesn't really make sense. You can write a, b, whatever name you can give. You can write everything in the main. It doesn't really matter. I'm just doing this to make things simple and clear. Okay, nothing else. So calculate postfix. What we will do is we will calculate the value, and to calculate the value we will use another stack to evaluate things. Okay, so we'll call this vector of float evaluation stack, because this stack is going to be used for evaluation. Okay, like we had 1 2 3, so like we have 1 2 3 and then division and then plus. Okay, in the previous example, what we will do is until we reach an operator, we will put everything in the evaluation stack, and whenever we reach into an operator, we will take the top two values from the evaluation stack and perform the operation, and after that we will put that value in the stack in that place. Okay, and that way we will continue our work. So we have the plan now, so let's convert our plan into code. And to convert but before that, I think we have to have a way to convert these strings into numbers, and for that let's include CLUD, let's include cstdlib, stdlib. Some of you know it as stdlib.h. It doesn't really matter. So now let's do it, the last step of our application. So we'll have our for loop, what we have been doing so far. So for let's say string token which belongs to our postfix. So for each token belonging to our postfix, postfix, for each token that belongs to our postfix, what is this? Oh, postfix. Okay, so each string that belongs to our postfix, first of all we will take the, we'll check if we have reached an operator. So if we are doing the same thing, so opmap dot find the token. So if the token belongs to an operator, so is not equals to opmap dot end. Okay, so if it is an operator, TOR. What we will do is we will take the top two numbers and obviously we will convert them from string to number. So float n1 is equals to evaluation stack dot the top two numbers. So we can just simply say evaluation stack dot size -1 for the first number and -2 for the second number. Okay, because the last index will be n-1 and the previous one will be n-2, so if the size is n, so we are just doing that, and this is a vector, so obviously we can take this kind of precedence. Okay, so now let's switch our operator. So switch switch our token en. Now we cannot switch strings in C, so we will just use token 0 to get the character out of the string, and we will declare the cases. So first case, if the token is addition, okay, then what will happen? N2 will be N2 plus N1, because we are at the end of the day we are going to push N2 again into the stack and remove N1. Okay, N2 is already in the stack, so we'll just remove N1, that will be sufficient, and then break. And we will do the same thing for addition and for the other operations like addition. So we'll just paste it a couple of times. Some reasons whenever I try to do that, it doesn't really work. So for minus we will do this case multiplication, we will do n2 equals to n2 times n1, then break, and then case division, we will say n2 equals to n2 by n1, okay, and then break. And n2 in the order will be before n1, so literally if it is 4 3 minus, we are doing 4 minus 3, because here 4 is n2 and 3 is n1. Okay, so after doing that, what we will need to do is we need to pop back our n1. Okay, so switch statement ends here, so we'll say evaluation stack dot pop back n1. Actually pop back doesn't need to specify it, because it will do the thing from the end, so we will just do 2 pop backs to get these 2 elements out, and then we will re-enter n2, because I didn't take n2 as a reference. If I take it as a reference, then we could just simply pop once. It doesn't really matter, these little operations. So for the sake of the tutorial, let's go with this. Okay, and so this is the case for if it's an operator, and we have dealt with it. Now if it's not an operator, but rather if it's an operand, so else if it is an operand, because we can only have operators and operands, we don't have any other options. So we'll say evaluation stack dot pushback our operand, and we will need to convert our operand into a number, and for that we will use a function from stdlib, which is atof, okay, string to float, nothing else. And here we pass the string as a c string, so token dot c underscore str. Okay, this function converts a string into a number, and then we put it in the evaluation stack. Okay, and at the end of the day, our evaluation stack will contain only one number, that is our answer. So we will return evaluation stack 0 because we will have only one number. So now we can do that. We can say that float result, and we can put enter here. So float result equals to calculate postfix, and here we will pass our tokens and op map, and at the end of the day we will just see out our result. So we will say see out result. Okay, and now let's run it and check it if it's working properly. So let's try with a simple one. So 1 plus 2 times 3, which is equals to 7, because 2 times 3 is 6 plus 1 7. And we can check different ones like 1 plus 12 by 3 minus 2 times 4, which is minus 3, and this is one that we started with at the very beginning. So as you can see that this is working. It can also work with brackets if I'm correct. So let's say 1 plus 1 into, let's say 2 into 2 plus 3. So first of all 2 plus 3 should be added and then it should be multiplied, and for some reason it didn't work.
So I did a little lookup, and the reason that the brackets are not working properly and the parentheses are working properly is because let's say we have our expression like 2 times 2 plus 1. Okay, in this case after this operator, essentially we have already pushed 2, and so the temp here, this temp that we are pushing, it becomes empty in case of this bracket. So what we need to do is we need to look, we need to take it into consideration and only push temp if temp is not empty. So we will just use a condition: if temp is not equals to an empty, then only you push the token. Okay, and the same thing goes here also. So we put it here like this. If temp is not empty, we push the token. And if we have done that, to do that, then if we run this program, we can see that if we give our expression like 2 times, let's say 1 plus 2 plus 3 by 5, then we get 4. That is 2 plus 3 equals to 5, 5 divided by 5 equals to 1, 1 plus 1 equals to 2, 2 times 2 equals to 4. So as you can see that it's working properly now in case of brackets also.
We can check any other things like 2 plus 2 plus 2 plus 3 times 1.4, and it will give us 10.2. 3 into 1.4 is going to be 4.2, and plus 6 equals to 10.2. So it works. So we have successfully created a simple expression calculator here. You can check the code in the GitHub link that I have provided at the description of the video, and you can try this. This is a very classic example that usually in learning data structures students have to go through. So I thought that I should write a practical example of this. If you like these kinds of videos, please give a like. It gives me some motivations to make these kinds of video, and if you have any kind of confusion, you can write your doubts and problems in the comment section, and let's try to make a very cool video next time. Till then, bye.